Hello class, today we are going to look at triangle sides. So in the last video we looked at the relationships between the angles of a triangle. Today we're going to look at the sides of the triangle. So the first thing we're going to look at is the triangle inequality theorem. What this says is that any side of a triangle must be shorter than the sum of the other two sides. So that's lovely. Let's take a look at this. Okay, so triangle inequality theorem. So we have these two sides here, 4 and 5, right? So which of these sides here could be the third side? Well, let's take a look at this. Let's just try 10. So what this says is, okay, if I use this, so round that up there, that's 4. We make it, and you see it's too short, right? Because these two sides are not longer than that third side, and so it's too short. I can't get a triangle out of this, so that's no good. No triangle. 10 is too big. What the? Alright. Okay, so what about 9? That's a little bit shorter. Well, let's see here. We line that up, and it still doesn't quite, maybe, is it? It's close. It's not quite there. If they are both the same length, so 4 and 5, that just adds up to 9, and you see that doesn't give me a triangle. That just gives me a segment. I don't want a segment. I want a triangle. So having them the same length as that third side, again, not good enough. But with the 8, well, see there, they're nice and long. And so there it is. We can have a triangle now. If I could make it actually line up and match. There you go. Triangle. Because 4 plus 5 is 9, and 9 is more than 8. Alright? So any two sides have to add up to more than the third side. Or the third side has to be shorter than the other two sides added up. Alright? That's how this works. Okay, so let's take a look at an example with this. So which of the following sets of numbers could represent three sides of a triangle? So we're just going to try it. Let's take a look here. So we have 15, 25, and 38. So let's see, 15 plus 25 is 40. 40 is more than 38, so that works. Okay, let's check the other ones. 9 plus 16 is 25. 25 is not more than 26, and so this doesn't work. 10 plus 15 is 25. 25 is not more than 27, so again, doesn't work. 13 plus 22 is 35, which is not more than 35, so that doesn't work. So there we go. We're going to submit that. There it is. So here's one, which ones could not represent the three sides of a triangle. So let's see here. 9 plus 13 is 22. 22 is more than 31, so that's a triangle. So that one's good. That one's good. 15 plus 18 is 33. 33 is more than 30. That's a triangle. We're good. 4 plus 9 is 13. 13 is not more than 14, so that's no good. And 6 plus 19 is 25. 25 is more than 22, so this one's a triangle, and we'll submit it. There it is. Okay, so here's another problem we may see with this. So if we have two sides of a triangle with a length of 8 and 10, what are the possible lengths of the third side? Well, you got a couple possibilities. Either 8 and 10 are the short sides, and you're looking for the long side, in which case what you have is 8 plus 10 has to be bigger than that third side. Or you have 10 is the long side, in which case 8 plus whatever the third side is has to be more than 10. So you've got two different things to look at. Now the first one, that's pretty easy. 8 plus 10 is 18, so 18 has to be more than x. In this case, all we do is we just subtract the 8, and so we have 10 minus 8, and x has to be more than 2. Now we do want to put this together into a single inequality. And when you do that, you always start with the smallest number, so 2. So we have is 2 is less than x, which is less than 18. All right, so you take your 2 and your 18 and you stick x in the middle. Now, if you notice, all we did is we just took 10 plus 8 and we did 10 minus 8. That's it. So we take our two sides here, we add them up, and that's the upper limit, or we subtract them, and that's the lower limit. So real quick, let's do one more example. I'm going to change my numbers here. So now our side lengths are 7 and 15. Well, all we have to do is subtract them and add them. So 15 minus 7 and 15 plus 7. So 15 minus 7 is 8. 15 plus 7 is 22. So our answer is that 8 is less than x, which is less than 22. That's pretty simple. All right. All you gotta do. We don't know what it is, but it's gotta be somewhere in between this. If x is less than 8, then your sides aren't gonna be long enough to reach the 15. If it's more than 22, then the 7 and the 15 aren't gonna be long enough to reach the 22. So it's gotta be. Notice these are less than. They are not less than equal to. Has to be less than. Okay. Next thing we're going to look at the Hinge theorem. This says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Yeah, that's a lot of math talk. So let's just take a look at this. Let's move that. Okay, so Hinge theorem. I have two sides of one triangle, 4 and 5, congruent to two sides of my other triangle, 4 and 5. And this angle is bigger than that angle, and therefore this third side is longer than the other side. All right? It's like a hinge. If it's on a hinge and it swings open, the big thing is the bigger that angle is, the longer this side gets. All right? And the longer that side, the bigger the angle. Okay? Now, for this to work between two different triangles, it's very important that the other two sides are congruent to each other. 4 and 5, 4 and 5. So these two sides are congruent to those two sides. If these sides are not congruent to those sides, then we can't compare them. We have no idea. Now, the other thing that's here, notice, is that the bigger the side, the bigger that opposite angle. That brings us to this. So again, the bigger the angle, the bigger the side opposite. The smaller the angle, the smaller the side, right? And notice as I move this, it doesn't really matter. Now the bigger angle is still opposite the bigger side. The smallest angle, 48 degrees, is opposite the smallest side. Right? And that's every time. It doesn't matter what you do with it, no matter where I put it, every time the smallest angle is opposite the smallest side, and the longest side is opposite the largest angle, right? Every single time that's going to happen. And this is largely due to the Hinge theorem, but every time the biggest side is opposite the biggest angle, which begs the question, what happens if the sides are the same length? So if the sides are the same length, both of them are 5.68, notice those opposite angles there are congruent to each other. So here we have this isosceles triangle, and the base angles are congruent. All right? Every time as I move it out, well, now those aren't the same length, are they? There you go. 6.76, 6.76, and we have 65 degrees on both of them. So if you have congruent sides, the angles will be congruent. But if the sides are not the same, the biggest angle, 67, is opposite my biggest side, 7.72. The smallest angle, 54, is opposite the shortest side, 6.76. All right, so we're going to do another example with this. Okay, so we're going to take a look at this example. And so we have triangle STU. TU is 11, US is 17, and ST is 18. We want to figure out which of these statements is true. So what's going to help us here is draw a picture. So let's draw a triangle STU. So STU, and let's see, TU is 11, US is 17, and ST is 18. Now notice, all of these statements over here, these are all about the angles. It didn't tell me anything about the angles, did it? told me about the sides. But I know that the biggest side is opposite the biggest angle. So let's see, all of these are saying this one's greater than that one is greater than. So it's going to start with the biggest one, right? The greatest one. So let's see it. 18 is my largest side, and that is opposite my biggest angle. So U is my biggest angle. That needs to go first. So that's either going to be this one or that one. Okay. So now let's look for the smallest side. The smallest side is 11, which means my smallest angle is S, which would be right here, S. And has T in the middle, because 17 is in the middle, so angle T is in the middle. So there's my answer. And there it is. All right. So, remember, the biggest side is opposite the largest angle. The largest side is smallest side is opposite the smallest angle. All right. So, hinge theorem, again, the bigger the side, the bigger that angle. And for this to work between two different triangles, those other two sides have to be congruent to each other. And triangle inequality, any side must be shorter than the sum of the other two sides. So if you're looking for that third side, all you got to do is you subtract the two, and that'll give you your smaller limit. You add the two sides you know, and that'll give you your upper limit. It has to be in the middle. And also remember that these other two sides have to be more than the third side. They can't equal, it has to be greater than. All right, so I hope you found that useful, and I will see you in the next video.